Hey, can you guys hear me?
Yes.
Yeah.
Thank you, ma'am. All right, so if you guys want to play along, you are welcome to. You can go to blackgirlshack.org/Friday Night Labs. The password is in the chat, and you can get the PCAP zip file, which we're going to be using to look at traffic this evening, and you can get the Wireshark display filters cheat sheet, which looks like this and just gives you one-stop place to find all of the correct display filters.
What's the password? Sorry.
It's in the chat.
Okay, thank you.
And we will get started about 6:05. So while we are waiting, if you just jumped in, if you would like to go along with us, you can download a PCAP zip file from the blackgirlshack.org/Friday Night Labs site. There's a PCAP zip file there, and then the Wireshark cheat sheet. And if you don't already have Wireshark, you can get it from wireshark.org/download, or if you want, you can just watch and do it later. It's up to you. The URL, it is blackgirlshack.org/Friday Night Labs. And the password is in the top of the chat window. Okay, hold on. Give me 1 second. Some folks are saying that they just joined and they can't see the chat from before they got here. All right.
What's the password?
Typing it now.
Get you some BGH. no sense. Okay, what's going on here?
Hey, Michelle, we can hear you talking. Can you mute yourself? All right, so it is 6:05. So I'm going to go ahead and get started. Can you guys still hear me? It just got super quiet. Okay, good, thank you. All right, so we're going to be doing Wireshark today. My name is Tanisha. I'm the executive director of Black Girls Hack. We're a nonprofit organization that is set up basically to help increase the level of diversity in cybersecurity and its leadership. So we offer like training classes, resources, study groups for like CEH and Security Plus to try to get people trained up so that they can get jobs in cybersecurity. So that's a little bit about me. You can follow Black Girls Hack on all of the social media things, and I'm going to put the link tree into the chat window. So I'm sorry, that's not right. It's basically Linktree slash Tanisha, and you can get the links to all of the things that we have going on, from the study groups to the Friday night labs to our Slack channel, Discord, things of that nature. So any questions before we go ahead and get started? All right, so what you will need if you're going to play along, there is a PCAP file that is here and a Wireshark display filter. So the PCAP file is a zip file. When you download it, it's going to open up, and there are 4 packet capture files in here. So the reason I provided you with this is because you know, everyone's network is going to be different. So if we just all started capturing traffic, it may be different for different people. And the other thing is some folks may not want to capture their network traffic for any number of reasons. So this is just to make sure that everybody's on the same playing field. Okay. So you should have Wireshark downloaded on your machine if you're going to play along. If you are downloading this on a Linux machine, then you need to make sure that you are running it either as sudo or as root, because you need elevated privileges to run it. And if you are running it on Windows, you can just execute it. If you want to, are interested in capturing traffic on your home network, what you can do is you can just say, you know, start capturing packets, and then it will start capturing things. But there's no way to limit what information is capturing. It's capturing everything that is being transmitted over your network. In my case, I am doing my Wi-Fi. So, you know, you can find a lot of information in here, but like I said, this is your personal information. So the files that you guys have are publicly available PCAP files. so that there's no one's, personal information in there, because, depending on what protocols you're using, depending on what things you have going on in your network, some of it may be insecure. Okay. So I'm sorry. Okay. All right. So what we're going to do is, if you are playing along, you can say file open, and the first file that we're going to open up is the K password one. So just in case, I had assumed that you do not have any knowledge about Wireshark. This document will be available at the end on the same website where the PCAP files are, but I want you to follow along and actually do this before you actually see, what it's supposed to look like. So the PCAP file is available on blackgirlshack.org/Friday Night Labs, and the password is in the chat.
Which file you said that we're using again?
So we're using the one that says K password. I'm sorry, K password.
Thank you.
No problem. All right, so Wireshark is a network protocol analyzer. So what it basically is the network that, it's a program that captures network traffic. So it can capture your network traffic on a wired or for a wireless, or if you wanted to, you could catch it on, capture it like on everything that you have going on in your network. Everything that it can see, it can capture regardless of the protocols. Okay, so the PCAP file is the name of the file. So if you were to capture some traffic on your network and then you save it, it gets saved as a PCAP file. You can also capture traffic from the command line using something like TCP dump. There's a couple of other ones that you can use to capture packets, and Wireshark actually has on their download area a whole lot of sample packets or sample PCAP files that you can use to analyze different types of traffic. There are a whole host of different protocols and information that you can use to be able to analyze the traffic. So they have different files classified in different areas. So depending on what type of traffic you're trying to see. So in the packet capture file, you could see information such as the sender and receiver addresses, the type of packet and protocol used, and the packet contents. So depending on what type of protocol is being used, sometimes you can even see, for example, open text password information, like we'll see some of that later, clear text password information. You can see like if somebody types something in the terminal, like that information will display exactly how it's seen on the screen. So depending on what you're using and how secure it is will determine whether or not you're able to view the information or whether it's encrypted. But even if it's encrypted, it's possible that you can be able to determine what's going on. So we're going to open up the K password file, and you're going to see several things. So let me show you how to open up a file. So we're going to just open up a line. So what we're going to do is I'm going to move this up so you can see it. So if you look in here, you see a lot of information. Okay, so this is specifically about the TCP protocol. So you'll see the source port is 1047, the destination port is 464. You also see that information down here. Okay, so if you're doing, for example, like a capture the flag or something like that, where they're saying, hey, we want you to find some specific type of information, you can do a search using the Wireshark cheat sheet to look for specific information, whether that's a specific IP address or it's a specific protocol or whatever it may be. Okay, so you guys may know from like, for example, your Security Plus studies that TCP packets have a sequence number. So if you're doing something that involves a sequence number, that information will be in here. Okay. You will also see flags. So when we say, for example, like you're going to send a Christmas flag, which has like, I think 3 or 4 different flags set, this is the place in the Wireshark packet that you can actually see. So in this case, this is actually a send packet that was sent. Okay, it'll tell you the size of the thing, the checksum, whether it's urgent or not, and then any options that were also selected when it is sent. So in this case, this is a TCP packet. So we showed you I showed you the send flag, the sequence number, and the source port and the destination port. So there's a picture of that in your handout that you'll get at the end of the class. So any questions so far? All right, cool. So also in the packet, you can also have IP. So there's TCP and then there's IP. So if you look in the IP protocol, you'll see that there's different information in here, including the time to live, flags, and as well as other information. So why this is important, and you also see like the source IP and the destination IP. Why this is important is that time to live information can tell you some important things about the packets that you're looking about as far as like where they came from, because it'll tell you, for example, you know, what type of system is being used, because some systems have very specific information that they include in the time to live. Okay, so time to live, if you're not familiar, is a hop limit that sets the lifespan. So what it does is it sends your computer sends out a packet, and it when that packet comes back, it reduces the number. So it increases the number, then reduces the number, so that it keeps track of where it's at within the network. Okay, and I also showed you the source and destination IP, which again is in the IP. So there's other information in here as well. You can find out information about what type of device was sent, depending on what's in the source information, as well as specific frame information, such as time, arrival, things of that nature. So you can find out a lot of information from looking at Wireshark packet captures, and including like password information, depending on what you're looking at. So in this first file that we're looking at, so in this first file that we're looking at, this is the Kerberos password exchange sent over TCP. Okay, so there are 19 packets in this file, and there's both K password and TCP traffic. So the way that we can tell that is if you sort by the protocol up here at the top, you'll see that there are 2 packets that are Kerberos password packets, and then everything else is TCP in this particular one. Okay, so when you get into a packet capture, the 2 things that I typically do whenever I get in here is I will click on a TCP and I'll say analyze and then follow TCP stream. This will give you a one page of the information that's contained. So most of this, as you can see, is encrypted, but what you can see at the top here is that there is a change password. So that's giving us a hint as to what's going on in this file. Okay, so the second thing that I do, and that's in analyze, follow TCP. You can also follow, for example, UDP streams, TLS, HTTP, etc. Okay, so the other thing that I tend to do when I get into a file is I'll say file export, especially if I'm looking for example, like something for a capture the flag, like it says, hey, there was the file that was transmitted. Can you find out what the name of the file was or what information? So I will export the list of objects, and sometimes you can find information and sometimes you can't. But there's various different ways that to export it. So you have to kind of look in all, 5 of these to see if there's anything in there. Okay, so of importance in this particular file that we're looking at. So if you follow the TCP stream, it tells you that there's a password change, and it also shows you some domain information. So you see something in that follow TCP that says bluearc.com. Okay, so the third thing that I do in here is I will say follow the endpoints. Give me endpoint statistics. So what this will do is this will tell you, depending on what protocol, so like either IP or IP version 6 or TCP, it'll tell you the computers, the host names that are involved in the conversation. So in this case, there's 2 IP addresses, the 10 dot something and then the 192 dot something. And it tells you how many packets that were sent. So we can see that there were 19 packets in the file and how much traffic that was sent. And it'll tell you, for example, none of this traffic was sent using IP version 6. It was sent over TCP. There's no UDP traffic. And it was sent, IP version 4, okay, over Ethernet. So like it would give you the MAC addresses. So this is the type of information that you want to get from out of the endpoints. So let's see what else. So if you select packet 1 and you right click and you follow the TCP stream and select show, so I'm going to select packet 1. So the packet numbers over here on the side. So this is packet 1. I have this sorted right now based on the protocol. So, but if you click on the number, it'll sort it back by number. So if you click on number 1 and then you right click and you say follow TCP stream, or you can do it through analyze, it shows you this. So you can also display this information different ways. So whatever this is, it's encrypted. You can see the bluearc.com in here. You can see that it's a password change, okay? So if you can change it, you can change this depending on what type of information. So this is what it looks like raw. This is what it looks like through YAML. It shows you like by through packet. So this is what was in packet 4. This is what's in packet 5. So YAML, if you're not familiar, is a human readable data serialization language and is commonly used for configuration files and applications where data is being stored or transmitted. So this is, we're transmitting information back and forth. So you can change the view. And sometimes you can find information in some of these different encodings, depending on how you look at the information. So for the most part, the default is ASCII, which is this, but you can change it if you need to. So any questions about any of that? All right, so if not, we're going to open up the next file, which is the Telnet file. So what's interesting about the Telnet file is that Telnet transmits information in the clear. So what that means for you is that if we say, for example, we're going to click on this first packet and we're going to say follow TCP stream. So as you can see, when you capture Telnet traffic and we say that Telnet is insecure, we say that because there's nothing hidden or obfuscated about this, what's in here, and about this stream, okay? So the person logged in using a fake login. They logged in using a password that was user. It was at this particular time. They did a ping of yahoo.com. They were connected, and then they did an LS to see what was in the folder, and then they exited. Okay, so there's nothing secret about what was done in a Telnet stream. Okay, because all the information is transmitted in the clear. So this is not this is not user and it's like secret coded. Like the password is user and the login was fake. Okay, so the information is in the clear. And that's just a, what is it called? Like a summary of all of the information that's in here, right? So in this particular file, we've got Telnet traffic and we've got TCP traffic, okay? And the stuff that I wanted to point out for this one is you can see the information, username and password are in the clear. All information in the terminal is in the clear, okay? So that's like how, like when people say like some things are more secure than others, depending on what you do, it can come through exactly like this, as opposed to the other one, which was the Kerberos, which is more secure, which you saw that most of it was encryption. You can still see certain information like that they were doing a password change and what the domain was, but you couldn't see, for example, what the password exactly was. Okay, so again, like I said, if you do analyze, endpoints, so it'll show you that there were 2 IP addresses involved in this conversation. They were both IP version 4. These were the IP addresses of them. There were 92 total packets sent in the capture. It was sent over Ethernet, and they were TCP. Which one was the Telnet? This is the Telnet file. So the Telnet file actually says telnet-cooked. All right, so are there any questions about the Telnet file? All right, so we will move on to the next file. All right, so the next file we have is the HTTP with JPEG. So what that file looks like in your folder is HTTP, WITP, and then JPEGs. So we're going to open that up in our Wireshark. And there are 11 packets in here, but we're going to do a lot of the same information. So the first thing we'll do is we'll say file, export, and I'm going to look and see if there's anything HTTP. So as you can see in here, there are a lot of, there were some pictures that were exchanged. There were some websites, some text files. There's a lot of different information. There was an application in here that was exchanged. So you can see the type of things that were done in the packet capture. So, you know, the application of this is that if you are doing, for example, some kind of engagement and you're asked to, you know, review what's going on the traffic to see, you know, if it's insecure, for example, you know, you can find out, for example, that, you know, this person downloaded some JPEG files, and you can actually say save all, and then, you know, save this JPEG and then see what it was a picture of. You can actually, you know, save this HTML file and see what they were looking at. So, you know, this is valuable information if you're trying to, for example, collect evidence, like if you're involved in something, or if you, you know, need to record how something happened. For example, if you're doing, like if you're a blue teamer and you're trying to figure out, you know, what was the extent, what happened. So, you know, there's several pictures in here, there's several websites, several applications in here. So like I said, that's one of the first things I do when I get into a file. I look at the endpoints. So this tells you that there were, looks like all of these, they communicated over different ports. So you'll see like a different line for each port. So it looks like there were four distinct hosts that were in this conversation. So 10.1.1, all of these four. This tells you the number of packets that were sent from each one and then information about those, okay? So this was sent over TCP, and it tells you like what port information it was sent over, and then over Ethernet. So you can tell a lot of information based on this. You can also, as I said, when you get into a file, you should follow the TCP stream to see what happened. So in this case, we see that there is a website, and the website has, you know, this is Ronnie Salberg's website, and then he's got some information on here, okay? So this is what the person was looking at. So as you can see, you know, you can piece together, depending on what the person is doing, you know, what they were doing while they were online, okay? So like if you, and I wouldn't suggest that you do this unless you own the network that it is that you're doing, but you can capture all of the packets, and then you can see, for example, like, you know, what traffic is my Xbox putting out? What traffic is my computer putting out? Like, what is this random device over here? Okay, so you can find out a lot of information about, you know, how the different devices connect, what type of information is transmitted, what protocols it uses by looking at the packet capture. Okay, so let's see. So in this one, we follow the TCP stream. We export the objects, and we were able to see, for example, all of the files that were in here. So there's a question. So how do you know which packet to look for the JPEG file? Because we have 10 HTTP captures there. Do you have to go through all of the HTTP? Okay, so the answer is no. So the way that you find out about it, so for example, if you say export objects and you're saying, for example, HTTP, right? So when you click on this picture of Sydney, okay, so this picture of Sydney was captured at packet 72. Okay, so right now, because we followed the TCP stream, we're only looking at like the information that was in the specific stream. Okay, but if we hit the X here, what we'll see is that there's a lot more packets in here. So there are 483. I don't know if you guys can see the very bottom of my screen. There are 483 packets in this file. Okay, so according to the export here, it says that the picture that the person looked at was at packet number 72. Okay, so when you click on that, you'll see that in the background, this jumps to packet number 72. So you'll see, for example, that there was a JPEG, and then it'll give you information about the JPEG itself. Okay, so not only can you download it and look at it, but it'll also give you information such as like how the picture was transmitted, whether it was broken up, things like that. Okay, so you also have, flags and time to live and other information that's transmitted through the IP protocol and through the TCP. You have the flags. So this particular one was sent as an acknowledgement and a fin and a push. Okay, so you'll be able to see the different flags that were sent in the packet as well. Okay, so and that's the same for any of the objects. So like in this case, you'll see that all of the traffic was done over HTTP, which is why when we export, we can only see things that are in the object list that were from HTTP traffic. So does that answer your question? Okay, perfect. All right, so, and like I said, how did you get all of the packets to show up? Okay, so at the top here, there's a filter. So if you tell it to, for example, follow the TCP stream, it will change it to TCP stream equals 8, and it will show you everything that's in this particular TCP stream, okay? So in this case, you'll see here, this is what was in the TCP stream, okay? But when you go back here, it's still green, it's still highlighted because it's only showing you a subset of the information. And you'll notice that the numbers over here are not in sequential order. So that will tell you that you're not looking at the entire stream. So if you hit this X over here, it'll take you back to the entire file. Did that answer your question? Okay, cool. Anybody else have any questions? And you can unmute yourself if you want to ask the questions out loud. But if not, you can surely type them. All right, so I think that's it for the HTTP file. So then we're going to look at the fourth file that we have, which is the little bit of everything. Okay, so that's going to be file open recent. I'm sorry, file open, and then this is the one that says enumeration. So one of the first things that you'll see about this file is that there are 33,000 packets in it. So this is a lot of packets. So for example, just for comparison, like if you were to do like some in-map scans, like or some ping sweeps, something of that nature, you may have a few thousand packets. If you were to do like in-map with like a dash flood, you may have like 200,000 packets. You may have like hundreds of thousands of packets, depending on how long you let it flood, whatever it is that you're pinging. But I wouldn't suggest doing that because, that can cause some trouble for you and that system. So like if you do it, just do it for like, a couple of seconds so you can end it and then see what it looks like. Okay. So in here, you'll see that there's a lot of different information. So for example, there is ARP traffic in here, and something else that you'll notice is that when you look over here on the right, like when you do for example, analyze and let's say endpoints. So there are a lot of TCP packets that were in here. So 10,442 over different ports, right? So sometimes you may see, for example, like if you get into a capture the flag, they may say, what was the lowest port number and what was the highest port number that was the attacker looked at. So in this case, you'll see that the lowest port number is port 1, and the highest port number is 65,389. Okay, so you know, when you're doing, for example, like some of these, like capture the flag, which are beginner friendly, you know, they'll ask you information just like, you know, can you determine, you know, what type of traffic, you know, what was the IP address that did it, things of that nature. So this file, unlike the other one, has some UDP traffic. So with TCP traffic, it gives you like the best efforts. So like there's sequence numbers, there's flags, there's source and destination ports, there's assurances to make sure that the traffic gets from one place to the other. Okay, so for UDP is kind of like fire and forget it. So there's no, for example, destination port. There's just like, hey, I'm sending this, or there's no source port. There's, you know, they don't want you to let them know that it got there. There's no like delivery confirmation. It's just like, hey, I'm going to send this, and if you're not ready, I'm sorry. If you didn't get it, I'm sorry, but you know, I tried because I sent it, and you know, everything after that, I'm not really worrying about. So you'll see in the packet, in this a little bit of everything file, that there is a lot of different information in here. And if we, for example, say, let's go down to our TCP, and we're going to follow the TCP stream. And there's nothing in here. But you'll see that, for example, this was a send and then a reset. Okay, so we talk about like how when you're doing a sending information, right, and you're making an initial connection with the computer, that you have a send, SYNAC, and then an ACK. That's the three-way handshake. So if the computer is not responding, which we'll get back, is a reset. Okay, like, hey, I got this, but you know, no one's here to answer your question. Okay, so all of these guys in red here are like, hey, no one's home. Okay, so I think, let's see, files to export in all but TCP. So if you look in here and you'll say file export DICOM, there's nothing in here. HTTP, you'll see that there are some HTML files. Lower check something, SDK file names. So you'll see information in there that might be interesting. You could download those files. File export SMB. So in this case, you can see that the host name, and they were connected to a share called PC, and then $, and it's a pipe type, and then / spools. So that can tell you some information about what it was that they were trying to do. Let's see what else. ARP broadcast. Okay, so when you first get on, when a computer first like is starting to look for something, it has to figure out who it is that they are conversing with. Okay, so they'll say, hey, I'm looking for something. In this case, this was an Apple device that was broadcasting a message, and they said, hey, I'm looking for this 10.0.6.18. You know, tell me who has it, right? So they're sending out an ARP broadcast to say, you know, tell me how to route this information to, you know, where I'm going. I need to know, you know, what's the next hop so that I can go there. Okay, and then remote shell. So packet 33663. All right, so if we look at 33663,
What if I don't have, like, my screen doesn't look like yours? Because at the side, my numbers just say 21, 22, 28, 29, 30.
Okay, so if you're the fact that the numbers are not in order makes me think that you have a display filter on. So if you hit the X button, which should be right here next to the thing, it'll clear it and then bring you back out here to the whole file.
I don't.
You want to share your screen?
I can't, hold on. I can't because I'm on my iPad.
Oh, okay. So if you look in the 33663, okay, you'll see that there was a remote shell that happened. Okay, so this is RSH information. It was the client to server. see what else did I want to tell you about this. So there's a ping that happens in packet 185, and there's LDAP that happens in PAT 20041. So there's a lot of information in this file that you can find. So like, for example, if we say send ACK and ACK, so the fact that this is an ACK, that tells me that if we follow this TCP stream here, we should get at least 3. We're going to see what was going on here. So in this case, this was, it looks like a website that they were visiting. And it's on an Apache server. But if we look at this, you'll see, for example, here's the SYN, and then there's a SYN ACK, and then there's an ACK. And so this is something that you may get tested on if you're doing like your CEH or your Security Plus, but like all of the packets in the stream after that all have the ACK set. So until they finish the stream, you know, the ACK is set after the stream has been established. Okay, so they may say, hey, you know, tell me which steps that the SYN ACK and the ACK happened in. So you can be able to look in here and say, you know, for example, this is in 33639. Okay, and you can see, for example, that this was HTTP. So like I said, this is what so right now we have this stream selected. So like I have an X here. So like, but I don't know on a Mac, like how you get back here to show.
I'm gonna sign on from my computer and show you.
Okay. So like if you were to sort this, you'll see, for example, here we have ICMP traffic. So ICMP is like a ping. So when you see a ping, and you'll see in your, like for the CEH, they tell you to know what the codes are, like depending on what, you know, what status the server's in, right? So this one is like destination and port unreachable. So if we look here in the ICMP packet, we'll see, for example, type 3, code 3. So this is one of the things that they ask you to remember, like if you're studying for the CEH, because that tells you, you know, not only is the destination unreachable, but the port is unreachable as well. Okay, and then you still have the same information in here as far as your, you know, IP protocol, which is your source and your destination, IP addresses, and then you also have, in this case, domain name information set with flags and whatever the query was. So, all right, so let's see what else do we have in here. SSL and 29127. Are you ready to share, Crystal?
Yeah, hold on.
Okay.
Yeah, hold on.
So does anybody else have any questions while we're waiting about like how do you search for information? How do you try to figure out information when you're Wireshark?
Can you see people credentials on protocol like HTTP?
Yeah, so like, for example, this one right here, this was sent over HTTP. So for example, you can say the same type of things that we do for the other thing. You can see if there were any objects associated with HTTP. In this case, this was a GET, so it was actually trying to pull a website down. So like you can find out what information is sending. Okay, so let's see, I don't think you had the right, this is not the right packet capture file. So if you move this, see where it says NO, and then it says like 17 dot dot dot. So if you widen this column here where it says NO on the far left, at the top underneath where it's that little banner where it says apply display filter. So if you open that up a little bit.
With this?
Like,
Wait.
yeah, like widen the number column.
Oh,
Yeah, okay, so they're the packet numbers. But is this the same file? Let's see. I can't see the bottom of your screen.
it says 200123 dash.
Oh yeah, okay. Yeah, that's it. That's right. Okay, yeah. So now you can see all of the file, all of the numbers, right? So like if you push the number field again, like if you hit the top column for the number, it should show you the bottom half of that. So that you should see all 30,000. If you scroll all the way to the top or all the way to the bottom, you should see all 30,000. There you go. That's the end of the packets. So you've got them all.
Okay, because you know how yours was like red and green, so I thought mine was wrong. Mine was wrong.
Oh, no. So I think that this is, I'm going to steal the screen back. So I think that you have to actually set it up so that it'll show you different colors. So like if you look on the right-hand side of mine, like this is separated by like types of traffic and then response. So like you'll see that, for example, all of these where it says that the TC packet was out of order. So it was pushed and acknowledged. So when we talk about in like the CEH study group about packet crafting, and you send a packet, like let's say you were able to sniff some traffic, you see that there was a certain sequence number, right? So you send a packet with a certain sequence number, you know, like that's maybe a couple numbers down, right? It'll say, hey, I've received this packet and it's out of order. So like I got this in a different order than the other packets that were part of this stream. So like it'll flag that, or the previous segment not captured. So like these black packets are the ones that are not expected, the ones that are not they were like malformed and they didn't, you know, they weren't a part of an established conversation. Okay, so you can set up Wireshark. And I don't, like I did it a while ago, so I don't remember like how to do it, but I'll find out for you. And you could set it up so that it has different colors depending on what types of traffic it has. Okay, so like
I used it for school before, and it was, I had those colors and stuff, so I thought mine was like wrong or something.
Oh no, it's not wrong. It just doesn't have like there's a way to have it like
original jurisdiction, meaning that we have always interpreted everything.
Can I get whoever just entered that's watching TV?
Oh, I'm sorry. I'm sorry.
Okay.
Right. I think she can go to edit and go to preferences and make those changes.
Okay.
She can see the color coding.
Edit preferences.
Fonts and colors.
Fonts and colors. Oh, there we go. So sample marked packet text, ignored packet, follow stream, client, sample valid filter. So you can set this up. Thank you, sir.
Thank you.
You're very welcome.
All right. So does anyone else have any questions? So what I suggest that you do if you're interested in using Wireshark for like, you know, your job, or you would like to just learn more about them, is that you can actually go to Wireshark and then get sample packets for them. So let me see. And again, I would get them from the wireshark.org website, not from anywhere else. And they actually have it set up so that, so like they have fuzz ones, they have different types, but there's actually another page. This must be the automated captures. But there's another page where they actually have them outlined, like these are TCP packets, these are, you know, UDP packets, so that you can get a look at the different types of traffic. So also if you're in the CEH study group, we have been saving, if you've done the labs, we've been saving Wireshark files. So next week in the study group, we're going to start looking at those files. So we looked for specific information. So we did specific scans. So we'll talk about, you know, for example, how where those scans started and ended, and then you'll be able to see that, you know, like I downloaded this file. This is what it looks like, so that you can be able to, you know, identify, for example, you know, what to look for when you're looking for specific types of traffic. So that's one of the other good things about the Wireshark download page, is that it gives you a lot of different types of traffic, so that you can see, for example, devices that you wouldn't even have on your computer normally. So I will make this document available on the website in, you know, maybe about an hour or so, so that you can see it. But the PCAP files will stay up there, so that you guys, if you were not able to play along with this right now, that you can go in there and take a look and search for specific things. And I included screenshots of the stuff that you're looking for, and, you know, where you can find specific information. So the information that I pointed out was information that, and there's actually, you know, pictures of Wireshark captures on the CEH exam. Well, they'll say, hey, tell me what the source destination is for this, or tell me what, you know, and I'll ask you to identify where specific information is in a sample packet capture. So if you're taking the CEH, this is good to know. If you're just maybe doing the Security Plus or earlier than that, then it's good for, you know, if you decide you want to do like capture the flags, or, you know, later on in your career. So it's good hands-on knowledge to have. And people actually do use Wireshark. So any questions? All right, so I don't see anything in the chat, so we will convene. If you want to get involved in more Black Girls Hack, like for example, study groups or our Friday Night Labs, the sign up is on Meetup, and you can find, yes, Wireshark is prevalent on the CEH. You might also see, for example, like an output from TCP dump, which is like a command line equivalent, but you can, you know, capture traffic from the command line and then send it to a file, and then you can look at the file there. But I think that Wireshark is more popular because of the fact that it's visual. You can color code it, you know, it's a lot more easy to look at than, you know, the limited window of the terminal screen. No problem. Any other questions? All right, great. Thank you. And like I said, if you guys want to follow us on all of our social media, so you can find out about like the resources that we have, or trainings or classes that we're doing a different topic every week. So next week, we're actually continuing over the wire levels 11 through 20, and you can just jump in at a level 11. You don't have to have done levels 1 through 10 to participate. So you're welcome to join us next Friday night. And yes, Security Plus Study Group is tomorrow. The Security CEH Study Group is on Tuesdays, Tuesday evenings. And we're also doing, if you join our Slack channel, we're doing the 25 days of Christmas Capture the Flag by Try Hack Me. So we do that every night from 9:30 to 10:30. So if you'd like to, you know, come and watch and see how those are done, you're more than welcome to as well. All right, well, thank you guys for coming out. Everyone have a good night.
Have a good night.
Thank you, you too.
You're welcome. Bye.